Assalamualaikum and hi everyone. See you again. In this video, I will discuss the tutorial question from your question bank for topic 6, which is alternating current. This is the part 2 for the tutorial discussion. In this video, I will discuss the structured question for question number 4, 5 and 6. In my previous video, I have discussed question number 1, 2 and question number 3. So you can refer to my previous video if you want to see the solution for the first 3 questions. For question number 4, figure 6.3 shows the root mean square voltage across a resistor R, an inductor L and a capacitor C. For question number 4a, by using a Phasor diagram, find the supply voltage and the phase angle between the supply voltage and the current in the circuit. So referring to the figure 6.3, this is RLC circuit. And from this diagram figure, there are few information that we have, which is the VR is equal to 141 volt, VL 327 volt, and VC is equal to 1.33 volt. Okay, by using the Phasor diagram, meaning that we need to refer to the Phasor diagram for the RLC circuit. So this is the Phasor diagram for RLC circuit, which is represent the VR, VL and VC, also the IRMS with the phase angle phi. Okay, from this Phasor diagram, if you want to calculate the supply voltage or the total voltage, so we use the equation of V square R plus with VL minus VC square. And we substitute the value inside the equation. So we get the voltage supply is equal to 240 volt. For the phase angle between the supply voltage and the current in the circuit, which is phi, we use the equation of tangent theta, which is tangent phi, which is equal to VL minus VC at the y-axis, divided by VR represent the x-axis. And when we substitute the value, we get the phase angle is equal to 54 degree. For question number 4b, we need to calculate the value of current flow in the circuit if the resistance of the resistor is 68 ohms. Okay, to calculate the current flow, we will use the equation of from the Ohm's law. VR is equal to IR, and the current flow in the circuit is equal because of the component is arranged in series. So when we substitute the value of VR and also the resistance given, which is 68 ohms, we get the current flow which is equal to 2.07 ampere. For question number 4c, we need to calculate the inductance and capacitance if the supply frequency is 50 Hz. So the given information is the frequency. So to calculate the inductance, we use the equation of VL, which is equal to IXL, and XL is actually referred to the 2 pi FL. So we substitute all the value, we get the inductance which is equal to 0.503 Henry. To calculate the capacitance in the circuit, we will use the equation of VC, which is equal to IXC, and XC is equal to I over omega C. We substitute the value and we get the capacitance of the capacitor, which is equal to 49.5 microfarad. For question number 4D, we need to calculate the resonant frequency of the circuit. So to calculate the resonant frequency, we need to use the equation of FR equal to 1 over 2 pi sed LC. The value for LC is referring to the calculated value in part C. So we will use the value, or we need to substitute the L and C in the equation. so that we can get the resonant frequency, which is equal to 31.9 Hz. Now take a look at question number 5. A 0.3 microfarad capacitor is connected to a source of alternating current with output voltage of 240 sin 120 pi t. For question number 5a, we need to calculate the reactance of the capacitor, and 5b, we need to determine the RMS current flowing through the capacitor. So referring to the question, the information given is the capacitance, which is 0.3 microfarad, and from the equation of output voltage, we get the hidden information which is V naught equal to 240 volt, and also the angular frequency which is equal to 120 pi radian per second. And also, if we refer to the question, this is the capacitor, the component is the capacitor, so it is a pure capacitor circuit. To calculate the reactance of the capacitor, we can use the equation for reactance, capacitive reactance, Xc, which is equal to 1 over omega c, and substitute the angular frequency and also the capacitance. So we get the capacitive reactance, which is equal to 8.84 kilo ohms. To determine the RMS current flowing through the capacitor, we need to calculate, we supposed to calculate the IRMS, the current that flow inside the circuit. So to calculate the RMS, we need to have the value of I naught. The I naught we can get from the calculation of V naught, which is equal to I naught Xc. Xc have been calculated earlier, so we just use the value, which is 8.84 kilo ohms. We substitute in the equation, and then we get the I naught, which is equal to 0.027 ampere. Now we substitute the I naught inside the IRMS equation. So we get the current, or the RMS current flowing through the capacitor, which is equal to 19.09 milliampere. Now take a look at question number 6. A circuit consists of a capacitor of 1000 microfarad which is connected in series with a lamp of 2.5 volt, 0.3 ampere, and a 50 Hz source. We need to calculate the reactance of the capacitor and resistance of the lamp, and also impedance of the circuit. Okay, if we refer to the question, this is the connection between the capacitor and a resistor, which is represent a lamp. So this is RC circuit. The information given inside from the question is the capacitance, which is 1000 microfarad. The value for 2.5 volt and 0.3 ampere is actually referred to the RMS value for voltage and RMS value for current. And the frequency given is 50 Hz, giving the hidden information, the angular frequency, which is equal to 2 pi f, or 100 pi radian per second. For the calculation of reactance of the capacitor, we just use the equation, capacitive reactance equation. So we substitute the value for angular frequency and the capacitance. We get the reactance of the capacitor, which is equal to 3.183 ohm. For the resistance of the lamp, we refer to the Ohm's law, or the equation of R, which is equal to VRMS over IRMS, and both value is given to us from the question, in the question. So when we substitute, we get the value for the resistance of the lamp, which is 8.33 ohm. For question number 6a2, we need to calculate the impedance of the circuit. So for the calculation of impedance, because of this is RC circuit, so the equation of impedance is equal to R square plus XC square, and we substitute the value that we have calculated, which is the XC and the R. So we get the impedance of the circuit is equal to 8.92 ohms. For question number 6 A3, we need to calculate the voltage of the source, and for A4, we need to calculate the voltage of the capacitor. So to calculate the voltage of the source, we will use the equation of V source equal to Iz. This is because of the circuit is the RC circuit, so we need to use the impedance where we have calculated impedance earlier. So we just substitute the value and we get the answer for the V source, which is equal to 2.68 volt. To calculate the voltage of the capacitor, we just use direct equation, which is Vc equal to Ixc, and Xc we have calculated earlier also. We just substitute in the equation, so we get the answer for the Vc, which is equal to 0.95 volt. For question number 6b, we need to explain why the total between the voltage across the capacitor and the lamp is not the same as the source voltage calculated in A3. So referring to the meaning of the question is why Vc plus Vr is not equal to V source. Okay, to explain this, we need to refer to the Phasor diagram, and referring to the Phasor diagram for the RC circuit, the VRMS lead VC, VRMSR lead the VRMSC by pi over 2 radian. Because of that, the V supply is actually represent the resultant voltage for both Vc and Vr. That's why the value for V source is not equal to Vc plus Vr. So that's it for the discussion for the tutorial question number 4, 5 and 6 from topic 6, which is alternating current. Thank you very much for watching, and I hope that you do take care of yourself and stay safe. I wish you all the best and good luck. And if you like this video, please click the button subscribe, like, and please share the video with your friends. If you leave a comment, I really appreciate that so that I can improve my next video. So thank you very much and see you in my next video.